All right, hello everybody. This is Forbes here with our next math lesson in our beautiful Math 1 curriculum where we learn all the great things, right? We're on to day 7. Day 6 was more so, I guess, notes with inequalities and equations. Today is more just really of the same. Here we're calling it solving equations and inequalities practice. Again, just practicing kind of the stuff we've been doing, just giving us some more opportunities, right? Writing equations for the context of the problems, writing inequalities in the context of the problem, being able to solve, read, interpret all the things, right? Again, the model is to pause and try them on your own, and then me is I'm just a guy doing some problems. Okay, so you just follow along as you need to. Let's start off with number 1. Again, it's more of a worksheet than anything today. Let's go to draw. Oh, I like red. Y'all know this by now. So each of the 10 students in the baking club made 2 chocolate cakes for a fundraiser. They all used the same recipe using C cups of flour in total. So the total amount of flour used among these 10 students is C. So it wants us to write an expression. Remember, an expression is just without the equals sign. That represents the amount of flour required for one cake. All right, so we know what the total is. The total is C. All right, but that's all the cakes. So if I want to know one cake, I need to divide by the total amount of cakes that I have, right? Well, I have 10 students making 2 each. That's 10 times 2 is 20 cakes. So I take the total number of flour, divide by 20 cakes, and I get my answer. Okay. All right, moving on. So that was an example of writing an expression. Let's write an equation here. An artist is selling children's crafts. So necklaces cost $2.25 each. Whenever you have something each or something per something, it's that value and then the variable. And we're also doing bracelets at $1.50 each. So I'm going to write it as simply as we always do. Let's do 25 for every necklace. I'll say N for necklace. And then we're going to add $1.50 for every bracelet B. Okay. And that's our expression. It says select all the combinations of necklaces and bracelets the artist could sell for exactly $12. So I want to know everything I can plug in for N and B that are going to equal $12. Okay. Now here's where I could write down a lot, but I'm not. I'm going to let you pause and try this on your own because it's going to become very repetitive really, really quick. So really, it wants to know all of the following values that could work. This is just understanding what it means in the context of the problem. So here, for this one, for instance, if I say 5 necklaces and 1 bracelet, I'm saying N equals 5. I'm saying B equals 1. So plug that in for N, plug that in for B, and then see if it equals 12. Again, I'm not going to write all those out, but I will tell you as you're trying which ones do work. I'm getting that the second one, and not this one, so don't think that one, but the second one, the third one, and this one right here, I'm getting that those are the only 3 that work. Meaning, if I plug, like for the instance, for the first one, if I plug in 2 necklaces and 5 bracelets into that, I get $12. Same thing for if I plug in 0 for N and 8 for B, it works. If I plug in 4 for N and 2 for B, it works. So those are all the different ways that it can equal $12. Okay? All right, very good. Number 3. Diego is collecting dimes and nickels in a jar. He has collected $22.25 so far. Good for Diego. The relationship between the numbers of dimes and nickels and the amount of money in dollars is represented by the equation. Now, you didn't need for them to give that to you because you know it's 10 cents for every dime and 5 cents or 0.05 for every nickel, and we know the total is $2.25. I wish that they didn't give this to you because, again, I think we are more than capable of writing that equation. It says select all the values D, comma N, so meaning the first number in all these ordered pairs are the D value, and the N value is always the second. That could represent the equation. So again, this is just like the last problem. I'm not going to write it out. Maybe I'll write out the first one just to show you what I mean. So I'm plugging in, so like 0.10, I'm plugging in, instead of D, I'm plugging in 0, plus 0.05, instead of N, I'm plugging in 445. And I'm curious what that equals. Does that equal to $22.25? I will say, if you plug that in the calculator, it does work. The other ones that work when you plug in for D and N, I am getting the second to last and the last one. So like if you plug those numbers into the equation and solve it out, it should equal 225. So understanding the equation and what values mean when I plug them in. Okay, that's kind of what we're doing there. All right, very good, very good. Let's move on to 4. 4 says, volunteer drivers are needed to bring 80 students to the championship baseball game. So we got 80 students total. Drivers either have cars, which can seat 4 students, or vans, which can seat 6 students. The equation 4C, so that means 4 students for every car, plus 6V, or 6 students for every van, has to equal 80. It describes the relationship between the number of cars, C, and the number of vans, V, that can transport exactly 80 students, assuming that we fill up the entire van and the entire car with students. So 4C, 6V. Again, we could have come up with that equation on our own. I wish it hadn't given it to you, but there it is. It says select all statements that are true about the situation. Again, these are like the last 2 problems. We got what a C value is. We got what a V value is. What happens when I plug 12 in for C and 2 in for V? What do we get? You're trying to see if we get exactly 80. Again, this is your chance to pause the video, test out the numbers, see which ones work and which ones do not, right? Hopefully you have plenty of time. I'm getting that all of these 4, let me do this in red now. I'm getting that this one, and this one all work. So the pair 14, 4, 6 and 11, 20, and 8 all work. But notice what they're saying. The pair 14, 4, so we plug in 14 and 4, is a solution, meaning you get exactly 80. But is this statement true? Like if I plug in 6 and I plug in 11, it works, but there will be extra space left over. Makes sense to me. If 20 cars go, no vans are needed, and 8 vans and 8 cars are numbers that meet the constraints in this situation. So those work, but the other 2's do not. All right. Let's move on to 5. The Drama Club is printing T-shirts for its members. The printing company charges a certain amount for each shirt plus a fee of $40. There are 21 students in the Drama Club. All right, part A. If there are 21 students in the club and the T-shirt order cost a total of $187, how much does each T-shirt cost? And show your reasoning. All right. So we know that the total, we know that what it's going to end up equaling is $187. All right. And we know that there is a setup fee of $40. That's an initial value, $40 plus. And we know that there are going to be 21 students that are ordering T-shirts. So there's 21 students, and they're going to, and wants to know how much does each T-shirt cost? Well, those 21 students are going to be paying for each shirt C. So I know 21 students paying C amount of dollars for each shirt plus the initial $40 is going to equal 187. So if you want to solve that, just solve for C. I'm going to subtract 40 from both sides. I get 147 equals 21C. And I can divide both sides by 21. And I'm getting that C equals 7. So that means that each shirt is worth $7. That logically, hopefully, should make sense. All right, what about B? The equation 20150 equals F plus 650 times 21 represents the cost of printing the shirts, a second printing company. Find the solution to the equation and state what it represents in this situation. So, all right, we got, let's write it out. We got 20150 equals F plus 650 times 21. All right. Well, first things first, if you multiply out 650 times 21, you get $136.50. Is plus F equals 20150. And we can subtract 136.50 from both sides. And we get, I'm getting that equals 65 equals F. Okay, well, think about what this equation is asking us for. It's saying, here's the total. Here is, think about this last equation right here. The 187 equals 40 plus 21C. It's the same equation. Here in this second company, we're paying a total of 201.50. And it's 650 for the 21 students. So just like this piece right here. So the missing piece that we found is right there. That's that same thing as that number right there. Well, what did that number represent? What does the 65 represent? It's the startup cost. It was $40 to start up for the other company. It's going to be $65 for the startup here. Startup price. Okay. Very good. Very good. Let's keep the ball rolling here. My says equations A and B have the same solution. All right. So it says, which statement explains why this is true? All right, well, let's think about it. Adding 3 to both sides of equation A gives x plus 7 equals negative 8. Well, no, because we're multiplying by a negative 3. So really, if I divide by negative 3, that would be true. So I get x plus 7 equals negative 8. So that's not right. Like, go through these like on your own. Try like each of these on your own and see if it's true. So it says applying the distributive property to equation A gives us x plus 7 equals negative 8. Well, again, that's not true. We didn't distribute anything. We divided both sides by negative 3 to give us this. So it didn't distribute, it divided. It says subtracting 3 from both sides gives us x plus 7 equals negative 8. Again, no, we're not subtracting. We are dividing. So the answer would be D. Okay. 7 says, zoom in a little bit. 7 says, is 0 a solution to 2x plus 10 equals 4x plus 10? Explain or show your reasoning. I love it when I ask these questions. Is 0 a solution? Well, if it's a solution, that means if I plug it in for x, it works. So is 2 times 0 plus 10 equal to 4 times 0 plus 10? Is that true? Well, 2 times 0 is 0, so I'm left with 10 on this side. 4 times 0 is 0, so I'm left with 10 on this side. So 10 equals 10. That is a big old check. So yes, when I substitute 0 into the original equations, it simplifies down to 10 equals 10, so therefore it is true. All right, very cool. Moving right along, we're doing great, guys. 8, the area A of a rectangle is represented by the formula A equals LW, where it's, well, length times width. And y'all should know that. It says, though, that the length of the rectangle is 5. I know that L is 5. Write an equation that makes it easy to find the width of the rectangle if we know the area and the length. So we know that area is equal to length, which in this case is 5, times width, W. So it wants us to make the equation easy to solve for width. That is a fancy way of saying, hey, get W by itself, please. And in order to do that, since we're doing 5 multiplied by W, we can divide both sides by 5. So I get that W is equal to A over 5, which is exactly what we want. I mean, that's an easy equation, given that we know the area and the length. Okay. Number 9. We are zooming, guys. Zooming. A car has a 16-gallon fuel tank. When driven on the highway, it has a gas mileage of 30 miles per gallon. The gas mileage, also called fuel efficiency, tells us the number of miles the car can travel for a particular amount of fuel. So 1 gallon of gasoline in this case. After filling the tank, the driver got on a highway and drove for a while. How many miles has the car traveled if it has the following amounts of gas left in the tank? All right. So it had, let's see, if it has, how many miles has the car traveled if it has the following amount? So it has 15 gallons. All right. Well, basically what we're saying is if that's the case, we can say 16 gallons. That's the total amount that we have. And minus 15, we get 1 gallon. So it has a gas mileage of 30 miles per gallon. Okay. So if there's 15 gallons left in the tank, and we started off with a full tank, we've only used 1 gallon. And we got 1 gallon for every 30 miles. So we used 1 gallon, that's 30 miles per gallon, so we have gone a total of 30 miles. All right, what about if there's 10 gallons left? Well, we had 16 total in the tank. We have 10 left over, so that means that we have 6 gallons, okay? So 6 gallons left, or we burned 6 gallons, so that means 6 gallons for every 30 miles each. We were able to go 180 miles. All right, we have 2.5 gallons left, so we did 16 minus 2.5. So the amount of gas that I used was 13.5 gallons. So if I go 30 miles per every gallon, that's 13.5 times 30. And I'm getting that to be 405 miles. And hopefully that makes sense. The more gallons we burn, the farther we can go. So it says write an equation. All right, think about everything we just did in each of these problems. We took the total that we had, 16, minus how much we had left, and then we took that value and multiplied it by 30. Now it wants a general equation here that represents the relationship between the distance, d, the car has traveled, and the amount of gas left in the tank in gallons, x. So x represents the amount of gallons we have left. So like, for instance, this was an x equals 10 here, x equals 2.5 here. Take all the things that we did and replace those with x's. So 16 minus x, and then we multiplied that number by 30. 16 minus x instead of 10, and we multiplied that number by 30. 16 minus x, and we multiplied that number by 30. So How do we get the distance traveled? We did 16 minus x, or the amount that we had left over, which in the previous problems was either 1, 6, or 13.5. And we multiplied that by 30. And that's our general equation. So however much gallons we have left, we can figure out how far we've traveled. Then it says write an equation that makes it easier to find the amount of gas left in the tank X if we know how far we've traveled. So remember what that means. It's just a fancy way of saying get X by itself, please. So working ourselves outside in, we multiplied by 30. Let's divide both sides by 30. I get D over 30 equals 16 minus X. I can subtract positive 16 to both sides. So I get D over 30 minus 16 equals, and that's a negative X. Don't forget about this negative right here. And then we can get rid of the negative by dividing everything by negative 1. And when I divide by negative 1 or multiply by negative 1, it changes the sign of everything. So really this is negative D over 30. Instead of negative 16, we get plus 16 equals positive X. And that's our answer. If you want to rewrite it to make it a little bit cleaner, you could switch these around and say 16 minus D over 30 equals X. Either one's fine. All right, very good. 10 says, find the solution set to the inequality. Boom. So solution set is the same thing as finding like a solution to an equation, but now we have a range of values. So just leave that symbol alone. And remember, we only alter the symbol if we divide or multiply both sides by a negative. So in this case, I'm trying to get X by itself. I don't like fractions. I'm going to try to multiply both sides by that 2 to get rid of it. And I can distribute it through. So I get 4x minus 6 is greater than, because we didn't multiply or divide by a negative number, so that stays the same. And we're left with 2x minus 5. I can subtract 2x and subtract 2x. And I can add 6 and add 6. So negative 5 plus 6 is positive 1. And then I can divide both sides by 2. Sorry, didn't mean to do that. But divide both sides by 2, and then I get that x is greater than 1/2. So meaning any value greater than 1/2 is going to make that solution set true, that inequality true. All right, let's try 11. Here is an inequality. What value of x will produce equality or make the two sides equal? So remember, this is greater than or equal to, so it wants to know the value that makes it exactly equal to. So essentially, solve it. Okay, just solve for the value that makes them equal. All right, in this particular case, let's see. I'm gonna write everything down. We got negative 10 plus x over 4 plus 5 greater than or equal to 7x minus 5 over 3. All right. Again, I don't like fractions, so why don't we multiply both sides? Let's get rid of this 4 on the bottom. Let's maybe do that. So I'm going to multiply this side by 4, and whatever I do on one side, I got to do on this side. So I distribute the 4 through. And the good thing about doing that is it cancels out with this one, but then don't forget to do 4 times 5, which is 20. So I get negative 10, I'm sorry, I already messed up. So 4 times negative 10 plus x, I'm sorry, the 4's did cancel out, so I'm left with just negative 10 plus x. And then 4 times 5 is 20. And then distributing this through, it doesn't simplify with the 3, so I actually have to distribute it on top. I get 28 x minus 20 over 3. And you're probably wondering, like, why don't I multiply it to the 3? Well, remember, this is the same thing as 4 over 1, so we only multiply, like when we multiply fractions, we multiply them across, and we're only multiplying that 4 to the top of the fraction. Okay? Now, again, I hate fractions, so maybe now I got this 3 right here I can get rid of by multiplying both sides by 3. Canceling that out, and then multiplying this by 3. So I get, let's see, 3 times negative 10 is negative 30, plus 3x. 3 times 20 is 60, greater than or equal to 28x minus 20. It's starting to look like a familiar problem. I mean, I'm seeing some like terms on this side I can combine together. So I get 3x. Negative 30 and 60 gives us 30. Maybe I will subtract 3x, subtract 3x, get 25x, add 20, add 20, and I get 50 is greater than or equal to 25x. All right, so I got 50 is greater than or equal to 25x. I can divide both sides by 25. And that is 2 is greater than or equal to x. So the value that makes this work is actually x equals 2. Like if I plug in 2 to this equation, the value is equal. But if I plug anything less than or equal to 2, I get something that just it works for the solution. Okay. All right, 2 more, guys. 12. A cell phone company offers 2 texting plans. People who use plan A pay 10 cents for each text. Good. People who use plan B have to pay $12 a month, but they only have to pay 2 cents for each text. There's a little bit of give and take there. It says write an inequality. Well, let's actually write those out. So A's equation, 10 cents for every text. That's just 0.1 times x. 10 cents for every text x. B's equation is $12 initially, but it's only 2 cents or 0.02 for every text x. So those are our 2 equations. It says write an inequality to represent the fact that, I didn't mean to do that. It's cool though. That it is cheaper for someone to use plan A rather than plan B. So if I'm saying A is cheaper than B, I'm saying that 0.1x is less than 12 plus 0.02x. All right. So plan A has to be less than plan B. So let's solve for x. Let's solve this inequality where this is true. So I can solve it like any other one. I'm going to subtract 0.02x from both sides. Do that in your calculator, but 0.1x minus 0.02x is 0.08x. And I'm left with less than 12. And I can divide both sides by 0.08. Oh, not the x, sorry. Just 0.08. Trying to get x by itself. And I get x is less than 12 divided by 0.08 is 150. So what does that mean? So that means anytime that I send less than 150 text, anytime I send less than 150 text, plan A is the cheapest. But once I go beyond 150 text, plan B becomes the cheapest. Because remember, it's a lot less cheaper per text, 2 cents as opposed to 10 cents. So if you're texting a lot, if you're texting more than 150 text, then it probably makes more sense to go with plan B. And then lastly, 13, it says, Claire made an error when solving this. What's the error? All right. So we got negative 4x plus 3 is less than 23. That's just rewriting it. We're good. Then we subtracted 3 from both sides, and we got negative 4x is less than 20, so we are good there. And then we divide both sides by -4, and we do get -5 and x left over. But what have I been beating in your brains about dividing or multiplying by a negative number across an inequality? It changes the sign. Okay? So that's where the error's at. She forgot to change the sign when dividing by a negative number. All right? There you go. So that's it. That does it for me. I've gone over my 30-minute mark, which I try to never do, but that is okay. Good job, everybody. Whoops. Didn't mean to do that. There we go. Congratulations on finishing this lesson, and I hope everybody has a fantastic day. I'll see you later. Bye.